we are going to talk about writing the equation of our parabola in vertex form given some information about the key features. So for the first part, if we are given information about the vertex, we know the h comma k value. We also then are given, in this case, the idea of the focus. So what I like to do is I like to take a little quick sketch. Doesn't have to be perfect, but I know I have my vertex here, and then my focus is at 3, 3 here. Well, we know that when we have a parabola, it always starts at the vertex and opens towards that focus value. So in this case, we know that this is a right-facing parabola, which means we are going to have a positive y squared value, basically. So this can help us start the setup, right? We know we have x minus our h value of 2 equals positive 1 over 4d, y minus our k value, quantity squared. Now the parameter d this time is always that distance between the vertex and the focus. So in this case, it only had to move over 1 unit. So basically we are plugging in 1 for our parameter d, which 4 times 1 is just 4. So our final answer just ends up being kind of that piece that we had before with 1 plugged in for parameter d. In our next example, then, we are given another vertex and focus problem. In this case, again, we are given the vertex, the h comma k, that's going to be at 2, 7. And then 29 fourths, if we're not 100% sure on that, 29 fourths is about 7.25, which means that it's just a smidge above that initial vertex that we had. So again, this is gonna open towards that focus point, in this case upwards, which means we're gonna have a positive x squared value. So again, we could plug in our h and our k. We would have y minus 7, and then 1 over 4 times d, and then x minus the h value, which is 2, quantity squared. This time there was an itty-bitty difference between these two. We were at 7 and 7.25, which means that our d value at distance is 0.25. Okay, so we could plug 0.25 in. Well, 0.25 times 4 is just 1. So our final answer here, we end up with just a 1 on the denominator. 1 divided by 1 is 1. Or we don't even officially have to write anything. If you could write the 1 out front, or we could just leave it as x minus 2 quantity squared. In our next example, we are given the vertex and the directrix. So again, I always like to start with a quick little sketch just to kind of see my shape. So here's my vertex. This time I have a vertical line, x equals -2 as my directrix. Now we always have a parabola that goes away from its directrix towards its focus, away from the directrix though. So in this case, this is going to end up being a right-facing parabola, and we know then that the y value is squared. Again, we are given that h comma k value on this one, so we would plug in x minus h equals 1 over 4d, and then y minus k quantity squared. Now, whether it be the directrix or the focus, the vertex is always going to have the same distance between the two of them, and in this case, that's going to come out to be 2 units. And again, even if it had been the focus, that would have been 2 units to the right. So in this case, 2 is our parameter d, so we are going to plug that in 4 times 2. So our final answer, we would just have x equals 1 over 8, y minus 4, quantity squared. All right, the last one is for you to try. Again, I would recommend a little sketch first, and then you can find the equation. Now, on the last page, we are given some examples. However, we are not given in this one any of the vertex points. We're given the focus, we're given the directrix. So on this particular one, again, I like to start with a little sketch. we are given a focus at 1, 2, 3, 4, 5, 6, comma 2. And then we are given a directrix through y equals -4. So that's down here, a horizontal line. Now, in order to find the vertex, you want to think about it almost as, again, the midpoint between these two. So the total distance between these two is 6 units, right? Well, we know that that vertex would come 3 units away from each of them. So 3 units above or 3 units below. So that's going to put us at the point 6, comma, -1, right? 3 units above or 3 units below our 2 y values here. And our parabola will always open towards that focus point, in this case, upwards. Well, now this turns into a little bit of what we were just doing on the last examples, because now we know it's an upward-facing parabola, so it's going to be y minus our k value, so y plus 1, and then 1 over 4 times our d value, which we know that that vertex is 3 units from either the focus or the directrix, and then x minus that h value, which is 6, quantity squared. So our final answer, this is going to end up simplifying to be y plus 1 equals 1/12 x minus 6, quantity squared. All right, in our next example, we are given a focus at 29 4, which we talked about on the last page. That's the same thing as saying 7.25, if that's a little bit easier for the graphing purposes. And then we have 27 4, which is 6.75. And basically what's happening is that focus is to the right, 1, 2, 3, 4, 5, 6, 7.25, and then 1, 2, 3, 4, 5, 6, 7, 8. So we're way down here for this focus point. Directrix is a vertical line through 6.75. So we only have this itty-bitty distance between them for our vertex to fit in between, and that's actually going to come at the x value of 7 exactly. So this time our vertex is going to be at 7, and then still down at -8 for our y value. And this time, again, we always open away from that directrix towards our focus point, so we're going to open to the right, which means we're going to have a y squared value. So our h and our k values this time, we would have x minus h, 1 over 4 times d, y minus -8 turns into +8, quantity squared. Well, our distance in between these two, we have itty-bitty between 7 and 6.75 or 7 and 7.25. Parameter d this time is an itty-bitty little 0.25 that we would plug in here. 4 times 0.25 is just 1. So our final answer is just x minus 7 equals 1 times y plus 8, quantity squared. All right, our last example for the day, again, gives us one focus and a directrix. This time we are all the way out at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -10, comma 2 for the focus, and 1, 2, 3, 4, 5, x equals -6 is our directrix point here. So in between these two, again, these two, if we're at -10 and -6, that's a total of 4 units between them, which means that vertex point is going to come 2 units from that directrix, 2 units from that focus point at x equals -8, and then it's still going to be up at +2 though. And we're going to open to the left, so we got to be careful. This is going to be a negative y squared value if we move to the left. So we have an h and a k value, so x minus -8 is x plus 8. 1 over 4d, we know it's going to end up facing downward, so negative. And then y minus our k value, quantity squared. Well, this time our parameter d we know is 2, because again, we are 2 units from either the vertex and the directrix or the vertex and the focus. So 2 is what we'd plug in for parameter D. And last but not least, always simplify. Again, we are leftward facing, so we need that negative. And then y minus 2 quantities squared. Okay. Last one is for you to try. Make sure you sketch a picture and then find the equation. Thanks everyone for watching. More of these in class.